Bismillah. Welcome to CSE370 Database Systems. We will begin with Chapter 1, Introduction to Databases and Database Users. This is the outline of Chapter 1. We will go over these topics in this chapter. Let's start with some basic definitions. Data. What do we mean by data? What is data? Data is basically any fact or figure that can be recorded and that has some meaning, that has some value. Data can be text, data can be audio, data can be video, data can be an image, data can be of any format. This is what we will store in our database. So what is a database? A database, simply we can say, is a collection of related data. Not random data, but related data. This is because a database is designed for a particular purpose. So let's say we're going to design a database to store the data of the students of Bragg University. In that case, the data in the database will only include the data of Bragg University students, not of any other university, not of any other institution. So a database represents some aspect of the real world, which is called the mini world. So if you are designing a database for Bragg University, then the mini world will be Bragg University. Let's say you're designing a database for a bank, let's say Bragg Bank. In that case, the mini world would be Bragg Bank. If you're designing the database for a hospital, let's say Lab Aid Hospital, then the mini world would be Lab Aid. So basically, a database is designed for a particular purpose, and it will store the data that is related, that is relevant to that mini world. A database comes with what is known as a database management system, DBMS. So the DBMS is a software package that is used to create and maintain the data in the database. So when the user wants to do anything in the database, add new data, delete data, modify data, that is done via the DBMS software package, which comes with the database. Okay, so this is Database Management System, DBMS. And database system, this term is used to represent both the DBMS software plus the data that is in the database. So database system includes both the DBMS software along with the data in the database. Now there are two approaches of managing data. One is file-based approach. This is the traditional approach of storing and managing data. And the other approach is database approach. This is the newer approach that is used to store and manipulate data. So we will give an example to illustrate both file-based and database approach, and we'll try to understand why we are gradually moving away from file-based approach and moving towards database approach. Okay, so by file-based approach, we mean that the data is stored in files, in flat text files, for example, WordPad or Notepad, basic text files. So let's say Bragg University wants to store the data of their students, and initially they are using files. Let's say initially they're using files to store the data of their students. So now Bragg University has many departments. We have CSE department, we have register department, we have accounts department, and so on. Each department now will need to store the data of their students in their files. So CSE department will have their own file, register office their own file, accounts department will have their own file regarding the students, and they will store the data of the students. Now, of course, the data requirement for each department is not the same. So, for example, registrar office, what kind of data do they want to store regarding the students? So, basic information like student ID, student name, address, phone number. And along with that, the registrar office will store the data about the transcript of the student. What courses the student took, what are the grades, GPA, CGPA, and so on. Okay. What about the accounts department? What kind of data does the accounts department want to store? Again, the basic information like ID, name, address, phone number will be there. And account department will store the financial data. What payment is due, what payment has been made, any fines, etc. So all financial information will be stored in the file of the accounts department. And let's say CSE department is the home department of the student. So what kind of data in the CSE department's file? Again, ID, name, address, phone number will be there, of course, plus CSE department related information, such as, okay, has he taken the prerequisite courses of a particular course? Is he on probation? Has he completed his graduation requirements? Is he ready to graduate? This kind of CSE specific information will be stored in the file of the CSE department. So in this way, BRAC University could store the data of their students in files. Each department will prepare and manage their own data file. Okay. Now, having explained the file-based approach, can we think of any potential drawbacks of this particular scenario of storing data in files like this? Can we think of any? Okay. Okay, let's take a look at this figure. So, let's say user 1 is from register office and user 2 is from account department. This is the file of the register office and this is the file of the account department. Notice that there is some overlap between the two data files. So, what is common between the two data files? Information like student ID, name, address, phone number, etc. will be common. So that information is in both the data files because both departments are interested. Account department only interested in your financial data, and register office interested in your transcript data. So that data is different, but some data is common, such as ID, name, etc. Okay. So this leads to an issue that the common data is being repeated in multiple data files. So this causes a storage waste. Because why? You are storing the same information multiple times without any benefit, without any value. So this is a waste of space. And another issue of this kind of data overlap is data maintenance becomes difficult. So let's say, for example, a student wants to update his or her mobile number. Now, where does the student need to go to update his or her mobile number? Okay, he needs to go to the register office because they need to know the new updated number. So the register office user needs to update the data in his file. But the account department is also interested in knowing the new number. So the student needs to go to the account department as well and update the mobile number there. And not just these two departments, CSE department, and there are many others like library, medical center, and so on. Each department has its own data file, and each department needs to update the mobile number of the student. So this is a hassle for the student as well as a hassle for the university because any change needs to be made in multiple places, right? Okay. Now what happens if the student, let's say there are 10 different departments in the university, the student needs to change the mobile number. Okay, he updates the mobile numbers in, let's say, 7 departments, but forgets to visit the other 3 departments. In that case, what will happen is 7 will have the new number, but 3 will still have the old number. So the student information will not be consistent across the departments in the university. Some will have the old number, some will have the new number. So this is a problem as well. Okay. Now, each department user will use some kind of application program to access the data. So they will not manipulate the data in the data file directly, but use some kind of application program written in Java, let's say, to access the data that is in the data file. But since each department has its own data file, the data file format, naming convention, etc., may not be same. So the application programs needed to access the data will have to adjust to multiple data formats for the different departments. So this is the hassle for the programmers, the software designers, who will write the programs to access the data in the different data files. So as you can see, in the file-based approach, the users are not very happy. Not very happy. Okay. Now let's look at the database approach. How can the database approach solve the problems that we just discussed in the file-based approach? Well, in the database approach, this is the figure that we want to look at. So here we have the data in the database. We'll have one database to store all the data of all the students in all the different departments. We'll not have separate files, but one what is called centralized database, which will be stored in a centralized database server. So all the data is stored only once. So the information like ID, name, etc. will only be stored once, but not repeated. Therefore, there is no waste of space here. And the data in the database is accessed via, as we discussed, the DBMS software, the database management system software. All the users of register office, account department, CSE department, and so on, they will have their application programs that will connect to the DBMS software. This will be in some kind of a server. So the users can access the DBMS through some kind of a network, like a local area network, LAN, or perhaps via the internet. So they'll connect to the DBMS, and via the DBMS, they can access the data in the database. So now, through the DBMS, when the data is accessed, there is one standard format for all the data in the database. So the application programs don't need to worry about different file formats of different departments. There is one standard format for the entire university, and the users can access the data in the database via the DBMS. So since here there is no waste of space, there is no repetition of data, data management is also much easier. So in this case, in the database approach, if a student wants to update his or her mobile number, all he needs to do is find the person who is managing the database. The data is updated once in the database. The mobile number is updated once. And immediately the new mobile number is visible to all the users of all the departments in the university. So it's much easier for the users of the database and much easier for the student as well. So as you can see, the users in this database approach are much happier. Okay. So this is the figure of a simplified database system environment. At the top, we have the database users and also the programmers who want to make use of the database system. And this is the database system. So let's start with the users, database users. Database users will write their queries in the SQL language. We'll talk about the SQL language, structured query language. The users write their queries in SQL. Via the DBMS software, now the query can be executed in the database. So the DBMS software will accept the queries written by the users. It will process the query, and then connect to the database. Now the database, you can say, has two different components. One is the actual data that is stored in the database, and the other is what is called metadata. Metadata is data that is used to define or describe other data in the database. So metadata is data that is used to define or describe other data in the database. This is the structural information of the database, and the stored database consists of the actual data in the database. So the DBM software will accept the queries of the users. It will connect to the database, run the query, and any result that needs to be returned is then returned back to the user. This is something that you'll soon see in lab, how to write queries in SQL, connect to the DBMS software, execute the query in the database, and then the result is returned to the user. It may be displayed on your screen. Okay. Programmers can also make use of the database. They will write the application programs in Java, etc. Inside the Java program, they will have SQL queries. When the program is running, when it wants to access the data in the database, the Java program will connect to the DBMS software and run the query in the database via the DBMS, and any data that is needed that is returned back to the application program. And then the application programmer can do whatever he or she wants with the data that has been returned to the Java program. This will also be shown to you in lab how this is done. In the After your midterm, when you start your project, you will understand how to write programs in Java or PHP, write queries inside your program, connect to the DBMS software, execute queries in the database, and get the results from the database to your program. Thank you.